40 million engines, 8 generations, 7 decades of dominance. The Chevrolet small block didn't just power cars, it revolutionized the entire automotive industry. From the streets of Detroit to the circuits of Le Mans, this power plant fundamentally changed how engineers approach engine design. In 1955, this compact V8 delivered more power per pound than any engine before it. The competition scrambled to catch up, but they were already years behind. This is the story of how an underdog project from Chevrolet's engineering department transformed into the most successful engine platform in history. Through innovative design, relentless development, and countless victories on the racetrack, the small block V8 earned its place in automotive legend. But the most surprising chapter of this engine's story isn't about its past. It's about what happened next. The birth of the small block came at a critical moment in automotive history. Post-war America was changing, the highways were expanding, speeds were increasing, and Chevrolet was falling behind. By 1953, Ford's flathead V8 dominated the market. Chevrolet's aging 6-cylinder engines couldn't compete. The pressure was on. Ed Cole, Chevrolet's chief engineer, knew they needed something revolutionary, but he faced a seemingly impossible challenge. The new engine needed to be powerful enough to outperform Ford, compact enough to fit in smaller cars, and simple enough for mass production. The conventional wisdom said you couldn't have all three. Cole assembled a team of engineers who broke every rule in the book. They started with a clean sheet of paper and questioned every assumption about V8 design. The team made radical decisions. They reduced the size of the cylinder bores. They shortened the stroke. Most controversially, they decided to use stamped steel rocker arms instead of the traditional machine ones. The engineering establishment called these choices reckless. Using stamped steel parts in a high-performance engine, it had never been done. But Cole's team had discovered something unprecedented. By reducing the engine's overall size, they could use lighter components. Lighter components meant less inertia. Less inertia meant the engine could rev higher and produce more power. The breakthrough came in the cylinder head design. Previous V8s used long, curved intake ports that restricted airflow. Cole's team designed short, straight ports that dramatically improved breathing. They positioned the valves to create a more efficient combustion chamber. These changes allowed the small 265 cubic inch engine to produce an astounding 195 horsepower. But the real genius wasn't in the power output. It was in the manufacturing process. Every component was designed for mass production. The cylinder heads could be cast in large numbers with minimal machining. The stamped steel rocker arms could be produced for pennies. The compact design meant smaller tooling and less factory space. The entire engine could be assembled faster and cheaper than anything else on the market. Production began in 1955. The first small blocks went into the new Chevrolet Bel Air. The response was immediate. Car magazines praised its smooth power delivery. Mechanics loved its simplicity. Customers were amazed by its performance. But nobody, not even Ed Cole, predicted what would happen next. Racers discovered that the engine was incredibly easy to modify. The simple design meant parts could be swapped quickly. The robust construction handled massive power increases. Almost overnight, modified small blocks started appearing in everything from drag racers to boats. The timing was perfect. America's hot rod culture was exploding, and the small block became its heart. Aftermarket companies sprang up to produce performance parts. Speed shops across the country filled with small block components. The engine that was designed to save Chevrolet had become a cultural phenomenon. By 1957, just 2 years into production, Chevrolet had to build a separate factory just to keep up with demand. The small block wasn't just an engine anymore. It had become the standard against which all other V8s were measured. Ford and Chrysler scrambled to develop competing designs, but they were fighting an uphill battle. The small block's combination of performance, simplicity, and affordability was unbeatable. Want to discover more untold stories from automotive history? Hit subscribe to join our community of gearheads and never miss our weekly deep dives into the machines that change the world. The true genius of the small block V8 lies in its technical DNA. Every millimeter of this engine tells a story of innovation. At its core, the engine succeeded because it solved problems that had plagued V8 designs for decades. The biggest breakthrough came from the cylinder head design. Previous V8s suffered from uneven heating. Some cylinders ran hot while others stayed cool. This temperature imbalance led to power loss and reliability issues. The small block team solved this through precision cooling passages. They designed water jackets that provided equal coolant flow to all cylinders. This simple but revolutionary change meant every cylinder could operate at peak efficiency. Raw numbers tell part of the story. The original 265 cubic inch version weighed just 531 pounds fully dressed. Compare this to Ford's Y-Block V8 at 665 pounds. The small block produced more power while using less material. This weight advantage came from sophisticated engineering rather than compromise. The block's rigid design allowed for thinner walls without sacrificing strength. The valve train showcased another leap forward. Traditional V8s used heavy mechanical lifters that limited engine speed. The small block introduced lightweight hydraulic lifters that were self-adjusting. This eliminated the need for constant valve adjustments while allowing higher RPMs. The stamped steel rocker arms, initially criticized as cheap, proved to be more durable than their machine counterparts. Fuel delivery marked another advancement. The intake manifold design created equal-length passages to each cylinder. This meant each cylinder received the same air-fuel mixture. Previous V8s struggled with uneven fuel distribution, leading to poor performance. The small block's design solved this through careful engineering of the intake runners. The oiling system represents perhaps the most underappreciated innovation. Most V8s of the era used complex oil passages that were prone to clogging. The small block introduced a prioritized oiling system. It delivered oil to critical components first, ensuring reliability under extreme conditions. This made the engine nearly bulletproof in racing applications. Manufacturing innovations were equally important. The cylinder heads used thin wall casting techniques that were ahead of their time. This reduced weight while maintaining strength. The block itself used 5 large bearing caps instead of 3, providing exceptional rigidity without excess material. These manufacturing methods became industry standards. One often overlooked feature was the engine's compact external dimensions. The small block could fit in almost any engine bay. This universal fitment led to its adoption in countless applications beyond Chevrolet vehicles. From boats to custom hot rods, the small block's compact size made it the go-to choice for engine swaps. The cooling system's design proved particularly forward-thinking. The water pump mounted high on the front of the engine, improving coolant flow and reducing cavitation. This seemingly simple change had profound effects on reliability. Even in high-performance applications, small block engines rarely suffered from cooling issues. These technical innovations created a foundation for endless development. The basic architecture could handle massive power increases without fundamental redesign. Engineers could improve individual components while maintaining compatibility with the original design. This flexibility ensured the small block's longevity long after its introduction. The small block V8's racing history began on February 20th, 1955 at Daytona Beach. 3 new Chevrolet cars powered by the then unknown 265 cubic inch V8 lined up for NASCAR's Speed Weeks. What happened next changed motorsport history. The small block powered cars dominated the competition, setting speed records that shocked the racing world. NASCAR became the engine's proving ground. By 1956, the small block's displacement grew to 283 cubic inches, and with mechanical fuel injection, it became the first American V8 to achieve 1 horsepower per cubic inch in factory form. This milestone sent shockwaves through the racing community. Teams that had dismissed the small Chevrolet engine suddenly scrambled to get their hands on one. The engine's success wasn't limited to oval tracks. At the 12 Hours of Sebring in 1956, modified small blocks powered Corvettes to class victories. European teams who had long dismissed American V8s as crude and heavy found themselves facing a sophisticated competitor. The small block combined American muscle with European-style refinement. The drag racing scene embraced the small block with particular enthusiasm. Its lightweight design and robust construction made it ideal for high-stress applications. By the early 1960s, small block-powered cars dominated NHRA events. The 302 cubic inch variant, specifically designed for Trans Am racing, became legendary in its own right. But perhaps the engine's greatest racing achievement came at Le Mans. In 1960, Corvettes equipped with fuel-injected small blocks faced off against Europe's best. Despite being newcomers to endurance racing, they proved remarkably competitive. The small block's reliability, combined with its power-to-weight ratio, made it a formidable endurance racing engine. Racing success drove continuous development. Teams discovered that the basic architecture could handle far more power than originally intended. The cylinder heads flowed better with minimal modification. The bottom ends stayed together under extreme stress. These attributes made the small block the foundation for countless racing engines. This racing DNA filtered back to production engines. Lessons learned on the track influenced factory developments. The high-performance versions got stronger blocks, better heads, and more sophisticated valve trains. The racing program essentially served as a high-speed research and development department. By the mid-1960s, the small block had racked up victories in virtually every form of motorsport, from short oval tracks to international road courses, from drag strips to hill climbs. These engines proved their worth. More importantly, they remained affordable and accessible to grassroots racers, democratizing motorsport performance. The small block transformed American car culture far beyond the racetrack. In garages across the country, this engine became the cornerstone of the hot rod movement. Its combination of affordability, simplicity, and performance potential created a new generation of automotive enthusiasts. Local speed shops built their businesses around small block modifications. The engine's standardized design meant parts from different years interchanged easily. Mechanics could mix and match components to create custom combinations. This standardization created a massive aftermarket industry. Companies like Edelbrock, Holley, and Crane Cams grew from small operations into major manufacturers. The small block's influence extended into popular culture. Car magazines featured monthly articles about squeezing more power from these engines. High school auto shop classes taught small block rebuilding as a standard part of their curriculum. The engine became so ubiquitous that 350 Chevy entered the general vocabulary as shorthand for reliable power. Industrial applications demonstrated the engine's versatility. Marine versions powered everything from pleasure boats to commercial fishing vessels. Industrial equipment manufacturers adapted it for generators and pump stations. The small block's reliability made it the default choice for applications requiring dependable power. Fascinated by automotive history? Join our community of enthusiasts and never miss our weekly stories about the machines that shaped our world. The international impact proved equally significant. Australian muscle cars adopted the small block as their primary power source. European specialty car builders, including ISO and Jensen, chose it over domestic options. The engine's worldwide availability and proven reliability made it the logical choice for low-volume manufacturers. In custom car circles, the small block became the universal solution. Its compact size allowed installation in vehicles never designed for V8 power. From British sports cars to German sedans, builders worldwide discovered the engine's adaptability. This universal donor status created unique automotive hybrids that would have been impossible otherwise. The small block's influence on engineering education deserves special mention. Universities used it as a teaching tool. Its straightforward design helps students understand fundamental engine principles. Many of today's automotive engineers started their careers studying small block architecture. The collector car market feels the small block's impact even today. Cars equipped with original small blocks command premium prices. However, the engine's widespread availability means classic cars can still be maintained and driven. This accessibility helps preserve automotive history by keeping vintage vehicles roadworthy. The small block created its own vocabulary. Terms like double hump heads, fuelie, and mouse motor became part of enthusiast language. This shared terminology helped build a community. Enthusiasts could discuss modifications and improvements using a common language developed around this engine. The small block V8 story continues into the modern era. While the original design ceased production in 2003, its influence shapes engine development today. The latest Generation 5 variants, powering modern vehicles, maintain core principles established in 1955. Modern small blocks showcase how fundamental engineering excellence transcends time. The current LT engines retain the original 4.4-inch bore spacing, but incorporate technologies their creators could never have imagined. Direct fuel injection, variable valve timing, and cylinder deactivation transformed the original concept for modern requirements. The production numbers tell an unprecedented story. Over 100 million small block-based engines have left the factory. No other engine design comes close to this scale. Current production continues at a rate of over 1 million units annually. The aftermarket continues to evolve. Modern computer-controlled engine management systems unlock potential the original designers never imagined. Forced induction packages routinely extract over 1,000 horsepower from production-based blocks. The robust architecture handles these power levels while maintaining reliability. Professional motorsport still relies on small block architecture. NASCAR Cup Series engines, though highly modified, trace their lineage to the original design. The engine's presence in professional drag racing remains strong. Modern electronic controls and fuel delivery systems extract maximum performance while staying true to the original concept. The environmental challenges facing the automotive industry highlight the small block's adaptability. Engineers develop cylinder deactivation systems that reduce emissions without compromising power. Alternative fuel compatibility allows these engines to run on ethanol blends. The original team's vision of an engine that could power everything from family cars to race winners has more than succeeded. Their creation didn't just survive the industry's evolution, it helped drive it. 7 decades later, the small block stands as proof that great engineering transcends time. But the small block wasn't the only engine that revolutionized American performance. While Chevrolet dominated with versatility, Chrysler was building something entirely different, something that would strike fear into the hearts of drag racers everywhere. The 426 Hemi took a completely different path to automotive legend. Click the video on your screen now to discover how this fire-breathing monster earned its nickname, the Elephant Engine.